My friends, good day. The story we're interested in today takes place in France on May 27, 2023. We have a pilot, he's 90 years old, and with him there's a passenger, probably his wife. Because at that age, it's very hard to find people who have faith in your piloting abilities. In any case, his age doesn't seem to have played a major role in the dramatic events I'm about to tell you. The plane is in Europa. It's a home-built aircraft, a single-engine propeller-driven touring plane with a fairly classic look. He's going to take off from Toulouse-les-Bordes to go to Gaillac, which is roughly northeast of Toulouse. So he's flying calmly. Everything is going well. He's a man with 1,800 flight hours and he's been flying for about 30 years. It seems that he got his private pilot license around the age of 60. It's definitely a late calling, but one that he will keep up until the end of his life. Unfortunately, this aircraft had been having a small problem for some time. That is, if we look at the engine and the propeller, we have an 80 horsepower Rotax engine, and we have a propeller, to put it simply, made of plastic. Actually, it's a composite propeller made by a French manufacturer. It's a constant speed propeller with an electric governor. You'll see that all of this will play an extremely important role today. So the propeller, the manufacturer, who unfortunately no longer exists, was a French company that made these propellers. He was able to build 3 or 4 blades a day and then ship propellers around the world, which were appreciated on ultralight aircraft and low-powered planes like this one. Unfortunately, just to tell you a little bit, the story is that one day there was an accident where during takeoff, a propeller exploded, so the blades flew off like fireworks, and due to the vibrations, the aircraft crashed. And it ended with 4 lawsuits against the propeller manufacturer. Actually, the guys who were in the plane weren't injured. There were 2 guys inside, but they didn't die actually. But they filed a complaint against the manufacturer. Still, it got so bad that the boss of the propeller manufacturing company told them at a trial, the worst thing that happened that day, the day of the accident, is that you didn't die. Imagine, I don't know, an American manufacturer like Hamilton saying something like that to the plaintiff during a trial. So can you imagine? It was a stain, the company shut down. But what I'd like to tell you is that it's very difficult for manufacturers of light aircraft or equipment like this to exist for a very long time. You'll see that very often they shut down because of a series of lawsuits they're facing. The story of the propeller is that it's a constant speed propeller. So it's a propeller that will keep its speed but vary its pitch. So the blades will hit the air at a different angle, depending on the power you use, depending on when you open the throttle. And this is regulated by a device, by what we call a governor, simply an electric governor. A big problem is that, in general, the propellers are managed by a mechanical governor. The advantage of the mechanical governor is that if it breaks down or loses oil, such as during a leak, it still functions. The propeller, in most cases, has weights that allow the blades to return to the smallest pitch. Which is the pitch we're interested in? C, more? In reality, it brings the propeller back to the smallest pitch. That's not the case for propellers that are regulated electrically. Which ones? There is an electric motor that moves them, that brings them back to a certain pitch. And if that one doesn't do its job properly, it can be a disaster. Okay, in the days and weeks leading up to this flight on May 27, 2023, well, the pilot was complaining that sometimes the governor was having trouble managing the propeller, so there was already a small problem. Generally, when we have this kind of issue, it's Providence trying to tell us something, trying to warn us about something. It's not happening by chance. A plane has to operate normally. If there's a recurring problem, if there's a problem that's sometimes there, sometimes not, intermittent, with all that, you shouldn't keep going. You have to stop. There's something wrong in any case. Our pilot continues toward Gaillac. He's getting ready to land on runway 25. And then what people will see is that he's coming in a bit too fast, a bit too high. Well, it's not the end of the world. It's not. We can't just say he's acting this way because of his age. It happens to everyone. Anyone can come in too high or too fast sometimes. So what he's going to do is At some point, he's going to overshoot the runway. So he'll fly over the runway without being able to land on it. And from there, he throttles up, so he goes. You can hear the engine noise increasing and the aircraft starts to climb again. But be careful, the aircraft isn't really climbing, there's just noise. Yes, there's a lot of noise, but the aircraft stays very nose up. It doesn't gain speed, it doesn't gain altitude, it's just a few dozen meters above the ground, and it keeps going. What's the problem? Here's the issue. Let me explain. It's that the propeller stayed at the high pitch. It couldn't return to a low pitch. It's like what would happen in a car. Imagine you're in a car with an automatic transmission and then it gets stuck. If you're in fifth gear going 30 kilometers per hour and want to speed up to cross an intersection, this actually happened to me. I was in the United States once and I had rented a Ford, and what happened was I arrived and saw the light turn yellow. I was going a bit too fast to brake. I didn't want to brake suddenly, so I accelerated. And what happened? Well, the car didn't go. Why? Because the gearbox didn't react properly. And so when you step on the gas, if you're slow, you step on the gas, but you might be in fifth or sixth gear, you can see that there's too much resistance torque for the engine and it won't go anywhere. That's exactly what happens when you have a propeller that stays at high pitch during a go-around, so the aircraft doesn't climb, so the aircraft struggles, but it doesn't climb, so what happens? We're in a situation, if you look, that corresponds to a blind spot in general aviation. Why? Because I've told you many times that here's the instructor, he reduces the throttle, he simulates an engine failure. All right, engine failure training is very, very common in general aviation, so in that regard, we have nothing to complain about. All instructors put their students through that. But there's something that corresponds to a blind spot that's very, very rarely studied. It's the loss of engine power, not a complete failure, because a complete failure actually has an advantage. The RPMs will drop suddenly. The engine noise stops and the propeller can even stop. If you're moving slowly, the propeller can stop completely. It doesn't always stop, so be cautious. You need to be going very slowly for it to stop. Otherwise, when the engine stops, the wind drives the propeller. So let's say this is a problem that's obvious enough to be noticed right away, okay? Right away. No engine. But the problem is, when you have a power reduction, it's not that obvious. Because on your dashboard, there's nothing obvious. You don't have any alarm. The noise is there. It feels like you're doing things right, but for some reason, it's not climbing. So, of course, you always end up figuring it out if you have time, but the problem is you don't have that time. What happened in this case is we have our pilot, he throttles up, climbs, but he can't make it. The plane stays very nose up, and the engine is making noise. And why was there this intermittent problem? You have to know one thing. In airplanes, there's the ground return. That means that very often you have a device. When you look at devices with direct current, what do they have? You have the positive, you have the negative. You normally have two cables going to it. The positive comes in, and then the negative goes back out. So we have a circuit like this. The problem is that very often in airplanes, we don't have a complete circuit with cables going both ways. We have a positive that goes to the device, the negative that comes out and goes to the metal sheet, so the negative leaves and gets attached with a nut somewhere on the metal sheet, so it avoids doubling the cables, so we have a ground return through the metal sheet. The problem in the case of this plane is that there was a nut that was coming loose. And that's quite surprising because it probably indicates that the construction wasn't very, very good. Why? Because normally all the bolts, the nuts in a plane, are what we call locked. That means we're going to take a metal wire and then we're going to attach it. We're going to tie them to a fixed point so they can't come loose. They can't come loose with the vibrations in a plane because planes vibrate. And we know that nuts don't hold on their own. The vibrations, if you take 50 nuts, you tighten them, you put them in a plane, you don't lock them, you leave them with the vibrations. You come back 50 hours, 100 hours later, you'll see that half of them have already started to work their way down the threads, all by themselves, spontaneously. Now, when that nut had come loose, it was connected to the cable terminal. Back to ground then, if you don't have a ground connection or you have an intermittent ground connection. What will the propeller governor do? It won't work because its circuit is open. And you can do whatever you want with it. You have no control over the propeller. So what's going to happen in our case is It's an electric propeller. When it loses the governor, it won't go back to fine pitch. When it failed, it was at coarse pitch, so it will stay at coarse pitch, and he'll increase the throttle. Engine noise, no power coming in, no thrust. So what he does is climb along the runway axis and make a left turn. And of course, when you're slow, nose up, have no power, and you're about to turn, you make things worse. No doubt about it. Even if the stall speed is 44 knots, that's still very low, which means to actually stall it, you have to be at 47 knots. He's really flying the aircraft at the limit. But here, if you bank it, you're going to increase the stall speed, so you'll stall more easily. And what happened here is that it rolled onto its side and headed toward the ground. So it hits the left wing first, followed by the front of the aircraft. At some point, it breaks at the bell, at the engine level, so it breaks in two. The pilot is fatally injured, his passenger is injured, but she will survive this crash. So maybe one of the lessons we can take from this, and I think I'll make other videos about partial engine power loss, because it's really, as I told you, the blind spot of general aviation. But one of the important points you should always check is when you're taking off or applying power again. Always analyze the engine parameters. They always do it in airliners, but in airliners there are two of them, sometimes even three. In some older aircraft, there's one who flies and the other who checks everything, making sure all the instruments are fine. Unfortunately, when you're in a light aircraft, you're alone, but that doesn't mean you're independent. You have to check everything when you accelerate. Check the revolutions per minute, check the oil pressure depending on the aircraft, of course, check the manifold pressure, check all of that. Develop a vision according to the aircraft, which of course varies. Develop a quick way of seeing to detect problems. Otherwise, if we have a partial power loss, we won't notice it. And this should be done during takeoff and of course when going around. So I think the gentleman crashed without ever understanding what happened. But again, I can tell you, I'll tell you another time. I was in a plane with a partial power loss during the climb. It's not that obvious, I assure you, it's not noticeable at all. At first you don't realize anything, you just have a power loss. It still takes you several seconds to realize there's a problem, and then you have to figure out where it's coming from, and all that while you're flying the plane. Good luck. Thank you, my friends, for watching until now. Thank you to those who support this channel, whose goal is really to do debriefs, to save lives. Thank you to those who support it on Patreon or by subscribing to the paid section of YouTube, and I'll see you in the next video.